हेलो फ्रेंड्स, आज हम लोग प्रैक्टिकल बायोकेमिस्ट्री में आगे बढ़ेंगे। चैप्टर 7 तक हम लोग कंप्लीट कर चुके हैं, जो कि कॉमनली यूज्ड लेबोरेटरी ग्लासवेयर एंड इक्विपमेंट्स था। अब 8th चैप्टर, जो कि है प्रिपरेशन ऑफ बफर्स एंड एस्टिमेशन ऑफ पीएच, इसको देखेंगे। चलिए शुरू करते हैं। तो चैप्टर 8, प्रिपरेशन ऑफ बफर्स एंड एस्टिमेशन ऑफ पीएच। कॉम्पिटेंसी नंबर BI 11.2, BI 11.16 and BI 11.19. Acid may be defined as compounds which yield positively charged hydrogen ion in solution, and bases are compounds which yield negative charged hydroxyl ion in solution. The net concentration of these ions determines the pH of the solution. pH is defined as the negative logarithm of the hydrogen ion concentration. Most often you are required to know or adjust pH of your solution accurately. The most accurate two methods for the determination of pH of a solution is first electrometric method and second colorimetric method. Electrometric method measures the electromotive force set up due to existence of H plus and OH minus ion in the solution. The instrument which measures pH in this way is known as pH meter. pH meter measures the electromotive force set up due to existence of H plus and OH minus ion in the solution. The pH meter has two electrodes, the reference electrodes and the glass electrode. Measuring ये pH meter है, figure 30. Reference electrode is made such that it has a potential of 0. It is made of calomel mercurous chloride, which is in contact with mercurous chloride in paste form surrounded with a solution of saturated potassium chloride. तो reference electrode क्या है, ये कैसे बनाया जाता है? तो is made such that it has a potential of 0. It is made of calomel and mercurous chloride which is in contact with mercurous chloride in paste form surrounded with a solution of saturated potassium chloride. The glass measuring electrode is a glass electrode with a silver wire covered with silver chloride dipped in a 0.1 mole per liter of hydrochloric acid. The tip of the glass electrode has a bulb of a special glass, low melting point and porous to H plus ion. It has a high resistance and the pH can be read off directly on a scale calibrated against non-buffers. They usually have a measuring range of pH from 0 to 10. pH मीटर, इसमें क्या क्या लगा रहता है? वोल्ट मीटर, ग्लास इलेक्ट्रोड, रेफरेंस इलेक्ट्रोड, 0.1 मोल HCl, H plus permeable glass not chloride. ये है मेजरिंग इलेक्ट्रोड, वायर टू pH मीटर, filling hole, AgCl coupled silver wire. Reference electrode, internal solution, AgCl reference electrode, permeable porous junction. glass electrode, internal solution, glass membrane, saturated calomel electrode, ESC, filing port, solution of unknown pH, reference electrode. The other method for determination of pH is the calorimetric method, which also is fairly accurate and can be used in the absence of a pH meter. It depends on the fact that certain organic dyes called indicator change color with changing pH. Each indicator Second the other method for determination of pH is the calorimetric method, which also is fairly accurate and can be used in the absence of pH meter. It depends on the fact that certain organic dyes called indicator change color with change in pH. Each indicator in its ionized state gives one color and in unionized state gives another color. In partially ionized states, the color is a mixture of its two colors shown in fully ionized and fully unionized conditions. The state of ionization of the indicator depends upon the pH of the solution. Each indicator has its useful range of pH within which it can indicate change in pH by change of its color, and beyond which there is no further change in color. For example, chlorophenol red is yellow when its pH is 5 or below, and red when its pH is 6.6 or above. That is, its useful range of pH indication lie between 5 and 6.6. The commonly used indicators are given in table 3 with their useful pH range and their color change. Indicator thymol blue, pH range 1.2 to 2.8, color change red yellow. Topfer's indicator methyl yellow, pH range 2.9 to 4.2, red yellow. Bromophenol blue, pH range 3.4 to 3 to 4.6, yellow blue. Methyl orange 3 to 4.4, red yellow. Brom cresol green 3.8 to 5.4, yellow blue. Methyl red 4.4 to 6.2, red yellow. Chlorophenol red 5 to 6.6, yellow red. Litmus 5.5 to 8.3, 4. Litmus 4.5 to 8.3, red blue. Brom thymol blue 6 to 7.6, yellow blue. Neutral red 6.8 to 8, yellow red. Phenol red 6.7, 8.3, yellow red. Thymol blue alkaline range 8 to 9.6, yellow blue. phenolphthalein 8.3 से 10, colorless red. Alizarin yellow 10.1 से 12.1, colorless yellow. Red yellow, red yellow, yellow blue, red yellow, yellow blue, red blue, yellow blue, yellow red, yellow, yellow blue, colorless red. Thymol blue, Toffler's indicator, brom, phenol blue, methyl orange, brom cresol green, methyl red, chlorophenol red, litmus, brom, thymol blue, neutral red, phenol red, thymol blue, alkaline red, phenolphthalein, alizarin yellow, colorless yellow. Universal indicators. By judicious mixing of several indicators, it is possible to prepare an indicator whose useful pH range will cover almost the entire pH scale. Such an indicator is known as universal indicator. The manufacturer provides color chart which gives the color obtained at different pH values. Such indicators are available in liquid form or in paper form. The universal indicator enables us to determine the approximate pH of a solution in one operation and thus help us to choose an appropriate indicator and buffers for subsequent more exact determination of pH of the solution. Chlorophenol red pH 4 pH 10, phenol red pH 4 pH 10, phenolphthalein pH 7 pH 10. Highly acidic red, pink, orange, beige, neutral. 7. Green, dark green. Turquoise, pale blue, blue, dark blue, violet, purple. Highly basic. क्या है universal indicator? pH determination principle. When equal volume of a known solution and a series of standard buffer solution with closely varying pH values are treated with a suitable indicator, the color of the unknown solution will be match with one of the standard buffer solution. The pH of the unknown is therefore the same as the pH of the buffer with which its color matches. Permanent standards made for glass discs of the appropriate color. Permanent standards made from glass discs of the appropriate color and shade for other indicators may also be used in place of the standard buffer and indicator. Helix comparator with its permanent standard discs made of colored glass is a very convenient instrument for this purpose. Helix comparator with its permanent standard disc made of colored glass is a very convenient instrument for this purpose. pH determination of a colorless solution. First, determine the approximate pH of the solution with the help of a universal indicator and its color chart. Take a small piece of universal indicator paper and just dip its one end into the given solution. After about 30 seconds, compare the color of the paper with the standard color charts provided and know, know the approximate pH. If universal indicator solution is to be used in place of paper, put a drop of it in about 2 ml of the solution and compare the color of the solution with that of color chart. After having know the unknown pH of the solution, choose from the set of indicator an indicator which most closely cover the pH range of the solution under examination. Then add a drop of this indicator to approximately 2 ml of the solution and match the shades of the color produced against the series of color standard buffers. The standard color solution are prepared by adding one drop of the same indicator to 2 ml of each of the buffer solution. The standard color solution are prepared by adding one drop of same indicator to 2 ml of each of the buffer solutions chosen in the pH range of the unknown. The pH of the unknown solution is that pH of the buffer with which the color matches. In case of the color of the unknown, in case the color of the unknown is intermediate between two colors produced by two consecutive buffers, the pH of the unknown lies between the two unknown standards. The accuracy of this method can be increased by employing set of buffer solutions with closely differing pH values. Determination of the pH of urine or any colored solution. The procedure for determining the pH of a colored fluid like urine is essentially the same as described for colorless solution. The only complication is due to the color of the fluid itself, which is over and above the color produced by the indicator. To obviate this difficulty, it is necessary to make the allowance for the natural color of the fluid. This is done most easily by placing a test tube containing plain urine or colored fluid in front of the colored buffer standard and viewing the two test tubes together and then matching this against the urine or colored fluid containing the same indicator, in front of which a test tube containing water has been placed. The use of a comparator makes the matching easier, else a double-rod test tube rack is also convenient. Light urine plus indicator, light buffer plus indicator, test tube, water, ice, urine, ice. Reagents. Set of indicators. The indicators are available either in solution form or as solid or in the form of papers. If it is in the solution form, it should be diluted to the required strength 0.04%. If it is obtained as solid, it is best to prepare neutral solutions of these monosodium salts. The indicators themselves being only slightly soluble in water. 0.1 gram of the indicator is taken in a glass mortar. About 2 ml of alcohol is added to moisten it and is rubbed up with the following amounts of 0.05 normal NaOH. If it is obtained as solid, it is best to prepare neutral solution of their monosodium salt, the indicators themselves being only slightly soluble in water. 0.1 gram of indicator is taken in glass mortar. About 2 ml of alcohol is added to moisten it. It is rubbed up with the following amount of 0.05 normal NaOH. Table 4 indicator thymol blue ml of 0.05 normal NaOH required for 0.1 gram indicator. थर्मल ब्लू के लिए कितना चाहिए 4.3 ब्रोमोफेनॉल ब्लू के लिए 3 ब्रोम क्रिसॉल ग्रीन 2.9 मिथाइल रेड 7.4 क्लोरर फेनॉल रेड 4.7 ब्रोम थाइमोल ब्लू 3.2 फेनॉल रेड 5.7 थाइमोल ब्लू अल्कलाइन रेंज 4.3 methyl orange only water, methyl yellow toffers indicator only alcohol, phenol phthalate only alcohol. Then water is added to make a total of 25 ml 0.4%. These stock solutions are diluted 1 in 10 with distilled water to make a 0.04% solution. In the case of phenol phthalate and methyl yellow toffers indicator, a 0.04% solution is made in alcohol. In case of methyl red, instead of using sodium salt, some prefer to dissolve 0.1 gram of the base in 300 ml alcohol and then dilute with 200 ml of distilled water. A standard buffer solutions. A convenient set of solutions have been worked out by Clark and Loves. A constant volume 50 ml of a standard solution of acid potassium phthalate, acid potassium phosphate, or of boric acid is measured into 200 ml volumetric flask. A constant volume 50 ml of a standard solution of acid potassium phthalate, acid potassium phosphate, or of boric acid is measured into 200 ml volumetric flask. A given amount x ml of 0.2 normal NaOH or HCl is then added and the volume brought to the mark with distilled water. The pH values obtained with different solutions are given in the following tables. A given amount x ml of 0.2 normal NaOH or HCl is added and the volume brought to the mark with distilled water. The pH values obtained with different solutions are given in following tables. If intermediate points are desired, they can be obtained by interpolation from curve drawn by plotting the tabulated values. 0.2 molar acid potassium perthalate dissolve 40.828 gram in distilled water and make up to 1 liter. The salt should be recrystallized from water and dried at 110 degrees Celsius for some hours. When recrystallizing, it is essential that temperature should not fall below 30 degrees Celsius to prevent the formation of a complex with some free phthalic acid. 0.2 molar acid potassium phosphate dissolve 27.231 gram in distilled water and make up to 1 liter. The salt should be crystallized from water and dried at 110 degrees Celsius for some hours. 0.2 molar boric acid in 0.2 molar KCl dissolve 12.405 gram of desiccated dried boric acid and 14.912 gram pure KCl in distilled water and make up to 1 liter. For 0.2 normal NaOH 5 0.2 normal HCl. Series A 50 ml of 0.2 molar acid potassium perthalate x ml of 0.2 normal HCl dilute to 200 ml. pH 2.2 46.70, pH 2.3 42.50, 2.4 39.60, 2.5 37, 2.6 32.95, 2.7 29.60, 2.8 26.42, 2.9 22.80, 3.0 20.32, pH 3.1, x कितना चाहिए 17.70, 3.2 14.70, 3.3 11.80, pH 3.4 9.90, pH 3.5 7.50, 3.6 5.97, 3.7 4.30, 3.8 2.63, 3.9 1. Series B 50 ml 0.2 molar acid potassium phthaleate x ml 0.2 normal pH and normal NaOH diluted to 200 ml. pH 4 0.40, 4.1 2.20, 4.2 3.70, 4.3 5.17, 4.4 7.50, 4.5 9.60, 4.6 12.15, 4.7 14.60, 4.8 17.70, 4.9 20.95. 5.0 23.85, 5.1 27.20, 5.2 29.95, 5.3 32.50, 5.4 35.45, 5.5 37.70, 5.6, 39.85, 5.7, 41.90, 5.8, 43, 5.9, 44.55, 6.0, 5.45, 6.1, 6.1, 46.20, 6.2, 47.00, 6.3, 48.10. Series C, 50 ml 0.2 molar acid potassium phosphate, x ml of 0.2 normal sodium hydroxide diluted to 200 ml. pH 5.8, x कितना चाहिए तो 3.72 ml, 5.9 के लिए 4.7, 6 के लिए 5.7, 6.1 के लिए 7.4, 6.2 के लिए 8.6 और 6.3 के लिए 10.19, 6.4 12.6, 6.5 के लिए 16. pH 6.6, x कितना चाहिए 17.80, 6.7 21, 6.8 23.65, 6.9 26.50, 7.0 29.60, 7.1 32.50, 7.2 35.00, 7.3 37.50, 7.4 39.50, 7.5 41.20, 7.6 42.80, 7.7 44.20, 7.8 45.20, 7.9 46, 8 46.80. Series D, 50 ml 0.2 molar boric acid in 0.2 molar KCl, x 0.2 normal NaOH dilute to 200 ml. pH 7.8, 2.61, 7.9, 3.30, 8, 3.97, 8.1, 4.80, 8.2, 5.90, 8.3, 7.30, 8.4, 8.5, 8.5, 10.4. pH 8.6, 12, 8.7, 14.30, 8.8, 16.30, 9.0, 21.0, 9.1, 24.3, 9.2, 26.0, 9.3, 29.95, 9.4, 32, 9.5, 34.5, 9.6, 36.85, 9.7, 39, 9.8, 40.80, 42.50, 10, 43. अब है कुछ क्वेश्चंस आंसर. When it is required to know the pH of blood, answer, one need to know about the pH status whenever we suspect that the patient has a clinical condition which will lead to change in the pH of blood. The different conditions that may exist are: first, metabolic acidosis, diabetic ketoacidosis, starvation, lactic acidosis, advanced chronic renal failure. Second, metabolic alkalosis, loss of HCl by vomiting, aspiration, respiratory acidosis, chronic bronchitis, emphysema, pulmonary fibrosis. Fourth, respiratory alkalosis due to hyperventilation, encephalitis, fever with septicemia. Salicylate poisoning. Question number 2. What is the pH of fresh urine? What are the physiological causes of change of pH of urine? The pH of fresh urine is usually acidic and varies from 5.5 to 7.5. The various physiological causes of change in urine pH are: acid urine, एसिड यूरिन कब कब होता है? पहला, इफ द डाइट इज रिच इन प्रोटीन, सल्फ्यूरिक एंड फॉस्फोरिक एसिड आर प्रोड्यूस्ड फ्रॉम द सल्फर एंड फॉस्फोरस ऑफ एमिनो एसिड्स। दूसरा, ड्यूरिंग द माइल्ड रेस्पिरेटरी एसिडोसिस ऑफ sleep या more acid urine may be found. तीसरा, therapeutic acidification of urine in treatment of some calculi, phosphate, calcium, carbonate, stone, which develops in alkaline urine by ammonium chloride. अल्कलाइन यूरिन कब आएगा? जब पहला, अल्कलाइन टाइड a few hours after a heavy meal, urine becomes slightly alkaline. Active secretion of HCl in stomach tends to make the blood more alkaline. To counteract this, the kidney eliminates some alkaline urine. If the diet is rich in vegetables, the urine is alkaline because the organic acid citric and tartaric present in vegetables are converted to bicarbonates in the body. तीसरा रीजन हो सकता है थेरेप्यूटिक alkalinizations of urine for removal of a small calculi, uric acid, calcium oxalates, cysteine, which develops in acid urine by sodium carbonate, potassium citrate. Therapeutic alkalinization of urine for removal of a small calculi, uric acid, calcium oxalate, cysteine, which develops in acid urine by sodium carbonates, potassium citrate. ओके, तो ये चैप्टर कंप्लीट हो चुका है। हम लोग मिलेंगे नेक्स्ट वीडियो में नेक्स्ट चैप्टर के साथ, चैप्टर नंबर 9, इंस्ट्रूमेंटेशन, कैलोरीमेट्री एंड स्पेक्ट्रोफोटोमेट्री। थैंक यू, बाय बाय। हंसते रहिए, मुस्कुराते रहिए और पढ़ते रहिए। बाय बाय।